Yeah, my name is Minko Gechev. I have been working as an engineer at Google, originally on the Angular team for the past 6 years, and for the past couple of months now, I've been lead across our multi-platform and web frameworks. And today I'll be talking about an LLM-first framework design. At least that was my original goal. I'm just curious, how many of you are using AI in your daily development process? All right, about 60% of the room maybe. And how many of you think that it's overhyped? Yeah, certainly, right? Me too. So recently I've been looking more into how we can improve developer productivity for developers using our frameworks by using AI. And my observation is that AI is here to stay. So I applied for this talk about 6 months ago, which in AI years is close to a century. So many things changed since then. And the topic of my talk is the same, but the content changed significantly. I was originally planning to talk about web framework that I designed specifically for LLM code generation. And since then, we released Gemini 2.5. OpenAI came up with GPT-5. We have also Anthropic with new models. And some of the hypotheses that I had, they're still valid, but they're maybe a little bit less noteworthy. So that's why I decided to split the presentation across code generation. We're going to still talk about the LLM-first framework that I experimented with a few months ago, but we're also going to talk about developer workflows and how we can enhance our developer productivity by using AI agents. So we're going to cover the LLM-first web framework design. We'll look into improving the code generation for existing frameworks. So if you're using Angular or React or any other technology, we'll see how you can get better results when you're generating code with simple tricks. We'll look into developer workflows and how you can enhance them to make them even better for you. And last, we're going to peek into future developer workflows that I think will be valuable in the future. But since this is my presentation, I'm also sharing my personal opinions here. I'm not really talking about my employer. So the beginning of 2025. Actually, this started about 2024. At some point, we wanted to add automatic code generation to the Angular playground. We wanted to have a place where you can enter a user prompt. We send requests to Gemini, we generate some code, and we allow you to quickly experiment with the latest Angular features, just with prompt-based UI. And around that time, we were using a snippet similar to this one. So you had Gemini 1.5 Pro. That was the main model that Google had. And you'd create an instance of the model. You'd pass the system prompt concatenated with the user prompt. You're going to generate some content, and the model is going to respond with just stream of chunks of text. Right now, using LLMs is not that much different, but just the model's capabilities change significantly. When we're talking about app generation, also, there are usually two main branches. We can talk about single-shot app generation, in which you just pass a prompt to the large language model, and you receive a response, stream of text. Or we also have repair loop. So you have the exact same thing as the single shot, but also when you get your application, if it doesn't run, you can take the error messages from the compiler together with the generated code, and you can pass this back to the model and ask it to fix it. When it has more context, it can potentially produce more working applications. In the first part of the presentation, we're specifically going to focus on single-shot app generation. That's what we attempted to do originally with Gemini 1.5 Pro. And the results, at first, were pretty good. In fact, we had a lot of working applications, but the success rate was not high enough for us to launch this product. Also, we had quite a few aha moments. I saw that Gemini 1.5 Pro worked really well with some structured data with JSON and XML, and with specific JavaScript constructs that were it was very familiar with. That some of them date back to ECMAScript 3, just functions and some basic operations. So at that point, I started thinking, is there an opportunity for an LLM-first framework that is designed specifically for this use case? And I was at a hackathon in Sarah's organization that Sarah organized. And I was thinking that maybe during this hackathon, I can hack quickly together like a framework that has some inspiration from the learnings of our initial prototypes and is potentially produces better results for code generation with LLMs. That's how I kicked off my small framework, Revolt. The key design principles there were that it is very minimalistic. It has a very minimal API surface, pretty much the bare minimum to build any like web application out there. You can declare components, you have component composition, you have content projection, you have some basic state management, and you have control flow. That's pretty much it. It is unambiguous, so you can do one thing in only one way. Like, for example, if you have a static binding or like if you have like a static value, it would always produce a signal binding because it's reactive, even though this value doesn't change. I wanted to make sure that the model has to think as little as possible, so it makes fewer mistakes as possible. Also, it is familiar to the model. I saw that it does really well with JSON, so I picked as a way to express your templates object literal, which were the closest thing to JSON that is expressive enough to enable you to express your templates. And the format for components, in fact, uses functions. And since I built it from the ground up, I want it to be finely reactive, so it uses signals. Here is a very simple application in Revolt. We have a couple of components, the user profile component and the avatar component. You can see that we have component composition in the user profile component, and the components are function components that just return object literals. These object literals just express this nested structure of the component tree. And every single binding in the framework is, in fact, a signal read. Again, I just didn't want the framework to have to think about whether it should produce a static value or pass a signal. It would always pass a signal. And this ended up working pretty well. The whole framework is on about 200 lines of code or so, and you can find it on my GitHub account on github.com/mgechev/revolt. So now we have the framework. In order to have running applications, we also need to pass some prompt to the model, right? That was my least favorite part when I started using LLMs, because just passing plain English, I really wanted to pass source code to feel good about it. But so I came up with a prompt in which I passed the entire implementation of the framework to the model, because I was hoping that this way the model would be better aware of how you can use it, since it's familiar of how the framework works. It worked out pretty well, and the whole framework is on 200 lines of code, so I was getting pretty good results. After that, though, I decided to optimize the prompt a little bit, sparing a couple of hundreds of tokens, by compiling Revolt to its type declarations and passing them to the system prompt instead. And that's what I ended up doing. So here is simplified implementation of the prompt, where we're pretty much passing the type declarations and only 3 examples to teach the model how to use the framework that it has never seen before. The 3 examples are a toggle component that just shows a very basic state management and conditional statements, a to-do component that shows the model how to use loops and some styling, and an example how to use effects. That's pretty much it. Also, I passed some guidance on visual styles because I wanted the applications to look specific way of cool that I like, and an output format to produce specific kind of like output format so I can stream XML. And since I have one more day from this hackathon, I was also thinking, why not build an IDE, like a simplified IDE that allows me to run these applications in the browser? Also, I saw all these companies are raising like hundreds of millions of dollars for vibe coding tool. Why not quickly prototype one during a hackathon? And here is the simplified Revolt IDE that has a chat UI with which I can interact with the model. I have a file tree that shows the file generated by Revolt, and finally the source code for the current file. And here is how it works. So I can quickly type a prompt, like let's say create a metronome app. I'll pass this user prompt together with the system prompt to the model, and I'll get an explanation of what the model does, and also the source code of the application. You can scroll to the bottom, like see the whole implementation of the Revolt like application built with Revolt, and look at the preview tab, which uses roll down, I believe, together with to bundle this whole application together and run it in the browser. You can find the simple ID that I just showed you on my GitHub account as well. And it was a lot of fun to build it. It was also a lot of fun to see for how many applications it works, when it doesn't. I kept running like hundreds of prompts through it. And after building a little bit more kind of systematic benchmark for it, I found that it produces working applications in over 99% of the time. So it has never, the LLM has never seen this framework before, and it still produces working applications 99% of the time. And around that time, I wanted to compare it with Angular, a framework that I was working on. I wanted to see how do these two frameworks compare to each other. Angular at that time was around 80%. Even though the model was trained on hundreds of millions of lines of Angular code. So I had a question, well, should we build yet another framework? Don't we have enough JavaScript frameworks? Or should we have yet another one? And that was definitely on the table. A new framework was something that I was actively thinking about. But also I was thinking about using Revolt as an IR. Imagine we generate a bunch of Revolt code from the LLM, and from there we use a deterministic compiler that takes Revolt and compiles it to Angular or React or Svelte or Vue, which would make a lot of sense. We know that we can produce Revolt code. We know that with Revolt we can express pretty much anything in all the other frameworks, so we can compile Revolt to them. Also, Revolt could be almost like a bytecode for frameworks in that sense. But there are also lower-hanging fruit tasks, such as just optimizing system prompts for existing frameworks. Around that time, the Angular team started building a whole infrastructure for benchmarking system prompts that could produce better quality Angular source code. And they kept optimizing these system prompts. Like iteration after iteration, they kept producing better and better source code. And at some point, Angular was scoring over 95% as well, actually 97 in the screenshot. And they reached working applications in like over 99% of the cases as well when they introduced the repair loop. It's a really cool project. I'll recommend you to have a look at it. The Web CodeGen Scorer. It is almost like a framework LLM benchmark. We have also implementation of, we have a template that uses Solid.js, and it produces just as good results as well, which shows us that just by using simple system prompts, we can achieve really high level of accuracy. You can find system prompts for Angular that allow you to produce significantly like higher quality source code on angular.dev/AI. They are prompts for pretty much all your favorite vibe coding IDs out there. All right, so what were the learnings out of this experiment? First, LLMs are good. I had a framework that the LLM has never seen before, and it was still producing working applications that I was satisfied with 99% of the time. There was also a lesson around LLM-driven design. We know about hallucinations of these AI models. They could be annoying, but also looking deeper into them, we can see that sometimes they kind of hallucinate things that make sense. So if the LLM keeps hallucinating the same API call every time, maybe it makes sense for us to implement this API so that the LLM hallucinates working code. I saw that to be valid for both Revolt, and we also saw a couple of cases in Angular, which the API were just missing in certain cases. It was somewhere back in our backlog, but we just couldn't prioritize it, and the LLMs helped us to push it back on the top, back to the top of the prioritization list. And finally, we also saw that there are plenty of opportunities in the tooling space. And that's where I would like to spend the second part of the presentation, agentic workflows and how we can become more productive with them. When I talk about agentic workflows, I'm talking about the whole array, from learning to developing, testing, and deploying your applications. Curious, how many of you here are using like Gemini CLI or Cursor or like Cloud Code? Anyone? OK, about half of the people. Yeah, these agentic IDEs, they're great for JavaScript developer, just as good, as great are for a Python developer, which is both a strength and kind of a weakness at the same time. Because there are plenty of tools that we can build to enable them to do better in certain environments than others. Let me show you how we can do that on a high level, just by looking at a very high-level overview of how they work. So we have a user, or that's going to be me, that is going to pass a prompt to the agent to build certain app or to implement a functionality in already existing application or debug certain use case. The agent is going to pass this prompt together with the system prompt and some kind of initial context to the large language model. And after that, the large language model is going to return like a plan of how we can accomplish the task at hand. From there, the agent is going to start executing different tools that the LLM suggested it to use. Let's say listing files in the existing directory or updating files, modifying them, or doing a web search so that it can provide more context to the model. And we're going to enter this state machine, or this loop, this agentic loop. And after a certain amount of turns, we're eventually going to either complete the task or give bad news to the developer that the agent has failed. How can we improve that? Well, the overall opportunity to improve this workflow is just by providing more context to the large language model through tools or through data, and by enabling more tools to make the agent more powerful, to be able to accomplish more. So we can develop these tools, or we can also provide better documentation for APIs that the LLM has never seen before, or through just markdown files, or with RAG, with retrieval augmented generation. Now, I'd like to just give you one example of supporting agents with advanced tools. And overall, the way we would provide these tools to the agent is through very famous, very popular protocol MCP, with which we create a server that contains a list of tools. We register this server. The agent knows about it. It can read these tools and provide them as something that the LLM can use to accomplish its task. And from there, they'll be just part of this agentic loop. Whenever the LLM is assigned to do something, it will just pick one of these tools that are relevant, and it would ask the agent to invoke it. The Angular team just shipped a MCP server for the CLI, and they have an incredible AI tutor that actually works really well. It will work in pretty much all the agentic IDEs there that you have on the market. It will teach you how to use some of the latest features of Angular. I really appreciate it. I was actually planning to add a demo, but it's running a little out of time. One thing about these tools is that kind of the baseline is that they do the bare minimum. So if you're using the Gemini CLI, you have tools for reading files from your file system, listing the files in the current directory, using some wildcards to find a little bit more complicated patterns in your file system. So overall, they're communicating with the file system. There is also a web search tool that allows you to query, open Google to quickly look up documentation, so you can teach the model how to use something particular. Something that they're lacking, though, is understanding the runtime, which I'll say is fundamental when you're building a web app. Because the source code is only half of the story. When you implement your application, you would compile your source code from, let's say, TypeScript to JavaScript. You would run it in the browser. And the browser is going to create a bunch of different data structures. Like some of them are covered in her keynote today, like the DOM tree, for instance. Or if you're using a framework, the framework would create a component tree and an injector tree, or a context tree if you're using React. From there, the framework's runtime is going to traverse these data structures and is going to produce your user interface. And there is so much that we can extract out of these data structures. All of the dev tools for Angular and React, all of them are reading these data structures and providing you insights through them. So we can enable access to this information to the agents as well. Let's look at a very simple use case. Let's say you would like to write tests for the current component on the page with its current state. What cursor will do is open a browser, headless browser. It would look at the UI, and it will try to guess what is the UI state of this component, which is going to be very incomplete. It will be able to see only what the component has decided to display, nothing from the internal state of the component, really. A better alternative would be to register a tool. Let's say here I'm using Gemini CLI because that's what I use on a day-to-day basis, but you can accomplish that with pretty much any agentic tool there that supports MCP. You can pass this prompt to the agent. It can open a browser with MCP, and this time, instead of just looking at the UI state, it can interact with the framework debugging APIs that are available on the page. It can find the component instance that you're asked for. It can read its local state, serialize it, and write tests for it, which is pretty powerful. You can do so much more. I'm going to show you a couple of more examples in my hypothesis for future developer workflows. All right, so when we're talking about the autonomy of agentic workflows, usually people present this axis where on the left-hand side, we have entirely hands-on workflows in which we write every single line of code manually. We run our tests manually. We open the browser to look at our application. We run Lighthouse manually. It is the process that we're used to, and pretty much that I fell in love with by building web applications. The hands-off use cases, you pass a prompt to the agent. Let's say, build a billion-dollar business for me. You wake up in the morning, and you have it. I don't know if we're going to get to the hands-off work, hands-off part of the spectrum entirely anytime soon, but we can definitely experiment with it and push the limits of what is possible today. So with everything that I showed to this point, with the source code generation, I'll say we're closer to the hands-on spectrum because the LLM would generate some code for us, and we'll have to review every single line of it. We can't afford to run LLM only produce code in production without ensuring that it doesn't have any security vulnerabilities or accessibility issues. If we add MCP support to interact with debugging APIs, we probably move a little bit more to the middle of the spectrum, but we're still pretty hands-on. Now, I'd like to share my hypothesis for what IDEs may look like one day. I believe that the best IDE for us as web developers is the browser itself, because it allows us to build web applications within the context in which the users are using them. So it makes us significantly more invested in the UI that we're building. We spent a lot of time thinking about these beautiful abstractions that compose really well together. And that's wonderful. I really appreciate it. I'm a big fan of design patterns and algorithms, and I'll continue writing them and enjoying them. But if we're building the web applications within the context in which the users are using these applications, well, we're going to hit the same issues that users are hitting. And eventually, we're going to get annoyed at them and fix them and make our application more performant and more accessible. So here is an agent that I was playing with and built like a couple of months ago. This is a very simplified version of Google Cloud Console. And in here, we can interact with the app. And also, there is this button at the bottom, which you can click on. And it opens a chat, which allows you to select component instances. And also, these are actually real instantiated components. These are not the source code representation of these components. These are the running components with their UI state. You can pass them to the context of the model, and you can also pass a prompt. Let's say create a page for Cloud Run, add a link to the navigation, and use the components in this form, use the components that I have selected in the form that you're going to create. When you press enter, we're going to enter this agentic loop. The agent is going to go through like discovering the files, reading the context that you provided, and executing. So you'll see that there is a page that would appear in the menu in just a moment for Cloud Run. The agent picked the icon that it found to be the most relevant. And here is the form, actually functional form, with the context that we provided to the agent. And that's actually a demo that I recorded from the first time. It was not something that I played with, like run it 15 times until I get a take that I was satisfied with. So this is powerful not only because we're using the agent within the context in which the user is interacting with the application, but also we're providing so much more data to the agent. We have access to every single instantiated component on the page. All these stat cards, project cards, action cards, the navigation, everything, including the routing tree and all the business logic in the injector tree, all the providers or all the services, the entire context of the application. So with this workflow, we probably moved from around here to closer to the middle. But let's see whether we can push it even further for certain use cases. I don't believe that agents will be able to figure out a design of a very complicated system from the first try anytime soon. But there are certain use cases that we can certainly optimize. I've been enjoying using these autonomous agents for mundane tasks that don't bring me that much joy, and there is not that much thrill in them. For tasks that repeat all over again, and I keep having to just do them so that I can continue with the things that I'm really interested in. How many times you've had UI that just didn't look great? Something like this here. And well, in these cases, I would open Chrome DevTools. I would adjust the styles in Chrome DevTools. I'll be happy with them. And now I'll have to figure out how to take all these changes that I introduced in Chrome DevTools and reintroduce them in my text editor or IDE so that I can replicate the effect that I got in the browser. Pretty annoying. What if instead of having to go through this manual cycle of manual DOM manipulations through Chrome DevTools and after that reintroducing them in your editor or IDE, you can just
improve the component styles.
So ask the agent to improve the component styles and it will fix them for you. That will be significantly easier. So that's a very basic example that honestly we would have been able to accomplish something like that a couple of years ago before LLMs. It was not going to be as reproducible, and it was going to work for only this one particular use case. Now with large language models, we can do that for a whole array of different tasks. And this goes through the same agentic loop. It uses the speech-to-text API to take your voice and turn it into a prompt. We, after that, collect the UI state. As you saw, I pointed over this card, and this added additional information to the AI model, letting it know what exactly UI component I would like to modify. And we pass this to the agent, which discovered the relevant files, reasoned about the rest of the application, how it looks like, and improves the UI styles. All right, so as a take from these presentations, AI workflows are here to stay for sure. And originally, when I saw how AI was messing up with my developer workflow, I was pretty unhappy. I really loved tuning my vimRC nights time before bed and playing with my dot files. And just seeing this way of interacting with a piece of software with English was somewhat dissatisfying. Now I see it, though, as an opportunity for us to significantly improve our productivity, be able to accomplish these mundane tasks that were bringing us less joy in the past, and make them more enjoyable so we can focus on what we are actually enjoying. Well, that's all I had for you today. Thank you for coming here, and we'd love to continue talking about this.